Hi, good evening, everyone.
Good evening,
Good
sir.
evening, sir.
ನಮ್ಗೆ ಇಟ್ಟನ್ನು ಗೊತ್ತಾಗ್ತದೆ. Just hold on a second. I will share the video. Today we are going to discuss a new topic, circles. Anyone can define the circle?
Sir, a polygon with infinite number of triangles.
Yes, still.
Sir, a closed figure with no edges.
Next. Many ways we can discuss. That's it.
Sir, it is a shape without any edges, and the points are all equal distance from a center point.
Yes. One of the good definition. Next. Any others? We already done the definition and some basics of the circle in grade 9. I think. Am I right?
Yes, sir.
Any other definitions related to circles? It's a very small topic related to grade 10. It's just a very small topic we'll have. Any other definitions? Look into the screen and let me explain any other definitions we'll have. Guys, still. Any other definitions?
So, circle is a closed two-dimensional figure.
We can discuss in a definite accept point of view. In a simplest way, to discuss the circle definition, I will give you one more statement. Look into this statement. Locus of all the points which is equidistance from a fixed point, or you can include here circle is a plane figure which will formed by locus of all the points. The locus means nothing but, instead of locus, if you are confusing, I can write this statement. Collection of all the points which is equidistance from a fixed point. This fixed point is called center of the circle. That equidistance is called radius. This collection of the points is called the diagram created by the condition. That is the plane figure of the circle. Is it clear, guys? What is exact? One more way of defining this. You can say it's a what is it? Infinity triangles and no edges. It's a quadrilateral or polygon with no edges, or infinity sides. A polygon of infinity sides. This is also one more point of view which can give the definition of the radius, the definition of the center, and the definition of the circle together in a single statement. Just collect all the points, join all the points which is equidistance from a fixed point. There are some activities we can do. I think we've done all these activities in grade 11, small grades. Just take the radii, a small thread, fix the small thread at one point. This is a 5 centimeter thread, and just mark all the points which is equidistance. Just rotate this thread about this one. So you will get a diagram like this. This diagram is called circle. This length fixed point is O is called center, and the distance between fixed point and any point on the circle is called radius. The points within the circle is called inside the circle, outside the circle. That means we can say if any point is based on the distance between the center, we can say that is inside the circle or outside the circle. If it is equal to the radius, then we can say it is on the circle. So circle is a boundary which will decides the distance between 2 points is greater than the radius or less than the radius. Different ways we can discuss. This is a basic definition of the circle. Is it clear? Any doubt in this?
No doubt, sir.
No doubt.
After this, we discussed the different parts of the circle. Anyone can explain the different parts of the circle?
Radius, diameter, tangent, secant, chord.
Yeah, first I am starting with secant. Secant is a line which will intersect the circle. Am I right? This is a secant, correct?
Yes, sir.
The secant is touching the point only at one point. If the secant is touching the circle only at one point, the secant is touching the circle only at one point, There are three possible ways you can draw a straight line. One, a straight line will never intersect the circle. A straight line will enter the circle at two different points as shown in the figure A comma B. A straight line, suppose P1, Q1, P2, Q2, P3, Q3, and this is a circle. If you observe these three lines, other than these three, any other possible ways you can able to draw the straight line in the space, in a plane or anywhere? Is there any other ways? Is it possible to draw a straight line which can intersect the circle at three locations?
Oh, sir.
So this is a general straight line. There is nowhere related to the circle and this straight line P1 and Q1. But P2, Q2 is intersecting the circle at point C, and there is only one point of intersection. In this case, the secant is called as what? Tangent. And if it is intersecting more than one point, at maximum it can intersect only at 2 points. So in this case, it is called secant. The line which is, if I am considering only the line which is in between the point of intersection, in this case, AB is called chord of the circle. Like this, you can draw many chords. With respect to the chord also, you can say, if the length of the chord is 0, then you can call as a tangent. And if you are drawing the many parallel lines, and on particular instant, the secant, if the secant is passing through the center, in that case, that is called diameter. I can say diameter is the longest chord of the circle. Is it clear, guys, what I'm saying? Any other definitions we are having with the circle? Yes, secant, diameter, chord, and radius. Half of the diameter is called radius. Yes, Niranjan. Yes, Niranjan.
Sir,
Yes.
what, sir?
Somebody's called me. So now how you can define a tangent? Anyone can define a tangent? Sandhya?
Sir, a line which touches the circle at only 1 point.
Yeah. Or one more definition here. Tangent is a circle. Tangent to a circle is a special case of the secant when the two end point of the corresponding chord is coincide. Or you can say a line which will touch the or which will intersect the circle only at one point, or a ray. Diameter. This is also a secant. It's a part of the secant which will pass through the center. The longest chord of the circle is called diameter. The least chord will occur only for the case of tangent, and the least chord length is 0. The maximum chord length is diameter. I think all these things we got in grade 9. These basic things, correct?
Yes, sir.
Now, the first one is we are going to discuss. It's a simple theorem. We don't have many things. The first one is the tangent at any point of a circle is perpendicular to the radius through the point of contact. That means wherever you draw the tangent in a circle, wherever you draw the tangent to a circle, Suppose according to the definition of the tangent, it's a line which will touch the circle only at one point. Suppose if this point I join to the center of the circle, here RS is a tangent to a circle and T is a point of contact of the circle. If I join center O to T, the theorem says this OP is always perpendicular to RS. The radius line which is joining the point of contact of the tangent to the radius line and the tangent is always perpendicular to each other. But condition is the radius line. What are the radius line you have to take? The respective radius line which is joining between the center and point of contact of the tangent. You take here. And here if I join to the point of contact, this is perpendicular. Suppose if I'm taking here. There is no much mathematical proof here. It's a simple proof. What he done here, he consider a circle with center O and he draw a tangent x and y. That x and y is joining at a point P. He took some other point Q. Take a point Q on xy other than P. So he took point Q is here. So the Q must be outside. When it is possible, according to the definition of the circle, the distance between the Q and O is must be greater than P, OP. So that is only he considered. So when it will be possible, when Q is approaches to P, according to trigonometry also we can say this is possible when both are at right angles. Other than at any point, if you take, it is greater than the radius. The Q lies inside the circle, xy become a secant. If Q is lying outside, it should be greater than the radius. So it will happen at every point of on x and y except P. So OP is the shortest distance. When you can say shortest distance from shortest distance between a point to a line always is a perpendicular distance. So this is how we can prove. We don't have any mathematical proofs to say. Only statement based only we will explain how it is perpendicular to this. Is it clear? So only one statement we have to keep it in mind. The line joining between the radius is always perpendicular to the tangent at that respective point. Suppose if I'm asking you to join radius at the point Q, this is a tangent, and if I join that Q to the center, that is always perpendicular. So take any other point other than that point of contact, and you say if it is inside, the point is inside, it is less than the radius and it will become a secant. If the point is outside, there are many points are available like that except one point. So that is the shortest distance. Shortest distance is always perpendicular to the line. You can take generally also. If I'm taking a line, if I'm taking a point, different distances I can design. Out of these different distances, there will be only one distance which is least value, and the distance line is always perpendicular to that line. Is it clear, guys? How to explain this theorem?
Yes, sir.
Yes, sir.
Anyone can try 10.1. It's a basic thing. How many tangents can a circle have? What is the condition to draw a tangents?
Sir, it should
What is the condition?
circle at only one point.
So at one point, how many tangents you can draw? How many points lying on a circle?
Infinite number of points.
Because we told very clearly, a few people told the definitions, infinity edges. Infinity sides. It's a polygon which is having infinity sides. That means it is having infinity vertices. So same way we can say we can draw infinity tangents because it is a combination of infinity points. N number of points we can define, and each point we can draw one tangent. A tangent to a circle intersects in how many points? What is the definition of the tangent? A secant which touches the circle only at one point. In that case only we'll call as a tangent. So a tangent to a circle intersects in how many points?
1 point.
Only 1 point. Why you are thinking? A line intersecting a circle in 2 points is called
Secant.
Secant.
a circle can have how many number of parallel tangents? At most
2.
maximum 2. That is the ends of the diameter. See, if you draw, how we can say this one? Draw a tangent here. Draw the n number of parallel lines. There will be only one more tangent will occur. So maximum a circle can have 2 parallel tangents at most. The common point of a tangent to a circle and the circle is called, what is the common point? This point is called what? What is that point? What is this? Point of the line containing the radius through the point of contact is also sometimes called as the normal to the circle at that point. What is the common point? Anywhere. The common point of the tangent and the circle is called point of contact. And the tangent is said to be touch the circle at the common point. So what is your answer? It's a point of contact, just. A tangent PQ at point P of a circle of radius 5 centimeter meets a line through center O at and Q so that OQ is 12 centimeter, then the length of the PQ. There is a tangent PQ. So I'm drawing the diagram. There is a tangent PQ at P, at a point P of a circle of radius 5 centimeters. The radius is 5 centimeter. Meets a line through the center O at point Q so that OQ is 12 centimeter. Suppose this is a Q, this OQ is 12 centimeter. Then he is asking what is the length of the PQ. I think this point of contact is P. A tangent PQ at a point P. So he draw the tangent at a point P and he extended that line. And there is the tangent is a PQ. He joined the center to Q. So according to the theorem, OP is perpendicular to PQ. If I am taking only the respective diagram, OPQ. So what is the length? What is the PQ value? What is the PQ value? Anyone?
Sir, 13 centimeter.
How, man?
No, sir. No, sir.
If it is PQ is 12 centimeter, then you can say OQ is 13. But here the diagonal is 12.
Sir, root 119 centimeter.
Correct. According to Pythagoras theorem, this is 12 square minus 5 square. So 144 minus 25. That will be equal to root 119. Complete the fourth question by your own. Fourth question answer I can write like this. This is a given line. This is a tangent which is parallel to given line. This is a secant which is parallel to given line. This is a one more tangent parallel to given line, or not required. That third one is not required. Tangent parallel to given line, secant parallel to given line. This is tangent line, this is secant line. Is it right? That question answer?
Yes, sir.
Yeah. Shall I go to the next one?
Yes, sir.
Yes, sir.
Next one is number of tangents from a point on a circle. Before going to this, just we have to think a little thing practically. How many regions? Suppose this screen is a plane. For example, this screen is a plane. I'm having a circle in this screen. So the total plane was divided into three categories. The total plane was divided into three categories. One is outside the circle. Second one is inside the circle. Third one is on the circle. So how we can say one point is outside the circle or inside the circle or on the circle? How? We already discussed just few minutes back. I discussed regarding of this. How I can say a point is inside the circle or outside the circle or on the circle? Subject point of view.
The way which line intersects the circle, sir.
No, how I can say, I'm asking, suppose if I'm giving a point here, this is a point P, there is a point Q, there is a point R. How I can say, take the center O and join all the three lines, all the 3 points from the center. O, there are 3 lines here, OR, OQ, OP. If OR is less than radius, OQ is equal to radius, OP is greater than radius. If any, the point, the distance between the point and the center is greater than radius, then the respective points are outside the circle. If it is equal to the radius on the circle, less than radius inside the circle. Other than these 3 possible conditions, is there any points that can exist in the plane? What are the point if I'm taking on the plane? What are the location I'm taking on this screen? Other than these 3 locations, anything is possible. So any point if you take in a plane containing a circle, the point must be outside the circle or in the circle or on the circle. Is there any other possibilities is there?
No, sir.
No. Yes. I'm going to the next step. Suppose the point is inside the circle. How is there any possibility to draw the tangent?
No, sir.
Point is inside the circle. There is no possibility of drawing the tangent. No tangents can be drawn. The second one is point is on the circle. There is a point here. So you draw n number of lines here. Out of n number of lines, how many lines you can consider as a tangent line? There will be only one possible line, correct? There will be only one possible line can able to consider as tangent line, because rest of the lines definitely it will meet one more time at the circle. Because of that, if a line is touching the circle at two different points, that is called secant. It is touching only at one point, that is called tangents. So point on the circle, how many tangents? Kamsini, how many tangents if it is point on the circle? Only one tangent.
One tangent.
If it is outside, suppose if I'm taking a circle, the point is outside, I can draw many lines. I can draw many lines from this point. But out of this, there will be only two possible ways I can draw. Which can be called as tangents. If the point is outside, we can draw two tangents with that common point. So first we have to know whether it is inside or outside or on. If it is inside, no tangents can be drawn. If it is outside, two tangents can be drawn. If it is on the circle, only one tangent can be drawn. Is it clear what is the condition or how we can explain number of tangent to a circle? Based on location of case one, no tangents because it is on the circle. The point is outside the circle, two tangents can be drawn. And number of secants you can draw, but you can draw only two tangents. Out of the n number of secants, only two possible lines can be the tangents for the respective circle. Clear, guys?
Yes, sir.
Now, the length of the tangents drawn from external points to the circle
Sir.